apologize I didn't record other class, so I'm going to put this on recording. So if you don't want to talk, don't say anything. If you don't want to be seen, don't come in front of the camera. That was Margot, by the way.
All I have to say.
What did you just say? Want to say that again?
Said gold.
Okay. Okay, so lecture 4 is, the topic is basically lecture 4A, we did multiplying. Lecture 4B, we're factoring, we're unmultiplying, going backwards. Okay? So do you remember back in elementary, they asked you to come up with what was called the prime factors? What are prime factors? So first of all, what are prime numbers?
Oh, do you want us to answer that?
Yes, what are prime numbers? I'm sorry?
1.
1 is not a prime number, but thank you for saying that. I appreciate that. 2 is a prime number. So 2 is the first one.
Woo.
What's the next prime number?
3.
3. What's the next one?
4.
No.
5.
5 is the next prime.
And then isn't it all odd numbers after?
Not all, because 9 is not.
Oh.
11, 13, 17.
So numbers that can't be multiplied
By other
by
than.
other than themselves.
Other than 1 itself, correct. So prime factors are numbers that have exactly 2 factors. Okay? By the way, it was Margot who got that right. So it's exactly 2 factors, which 1 is not a factor because it only has 1 value, 1 times 1. Negative numbers aren't, because like 3, you'd have 1 times negative 3, and you'd have negative 1 times positive 3. 4 factors. So it has to be 2, 3, 5, 7, has exactly 2 factors. All right? So do you remember back when you were in, I don't know, when they did this, 5th or 6th grade, they gave you a number like, let's say, 40. And they said, okay, let's break it down to prime factors using the factoring tree. Okay, so what are 2 factors that go into 40?
4 and 10.
4 and 10, or 2 and 20. So let's go with 4 and 10. Are either one of those 2 numbers prime? No, because they're both even. Okay, 2 is the only even prime number. So this is not prime. So you have to break each one down. 4 goes down to 2 times 2, and 10 breaks down to 5 and 2. So what you have is 2 times 2 times 2 times 5, or 2 to the 3rd times 5. And those are your prime building blocks that will multiply to equal 40. And it doesn't matter if you started with, let's say it started with 8 and 5. 8 times 5 is 40. Excuse me. 8 goes down to 2 and 4, which goes down to 2 and 2. You still get 2 times 2 times 2 times 5. Doesn't matter what you start with, it will always go down to the same building block, the same prime number. So that's what we're going to do today, except we're not going to do it with numbers, we're going to do it with polynomials. We're going to break it down to its primes, okay? So number 1, Roman numeral 1. This is always the first step. Always, always, always. I'm going to try to trick you later and I'll say, okay, what's the first thing we do? You always say this answer, and that is the greatest common factor.
Oh, I remember this.
In other words, you're looking for what number or letters will go into every single term, and what's the largest? What's the largest common factor, the largest value they have in common? So let's give you an example. Something like 2x to the 4th plus, oops, I was thinking 4 and I wrote 5. 4x squared minus 10x. So you look at each one of those, the numbers first. Let's look at just the coefficients, 2, 4, and 10. What's the largest factor they have in common? 2. They're all even. 2 goes into all of them, take out 2. All right, what's the largest variable they have in common? So if they all have the x variable, right? So then you take the smallest exponent. 4, 2, 1. So the most common one is x to the 1st. So if you just want to put x, or you can put x to the 1st if you want. So what do they have in common? Coefficients, and then the x's, you take the lowest exponent. Okay. Now, how do I factor? What operation do I do? Think of division. So if you take 2x to the 4th divided by 2x, you're left with just x cubed. Okay? I take 4x squared divided by 2x, what do I get?
2x squared.
Mm,
Wait,
Yeah, just
2x.
just 2x, very good. Minus, take 2x out of 10x, and you're left with just 5. Now these then would be your prime factors, if you will. We just broke down the factoring tree for those two factors. Okay, now greatest common factor is one of those things we reviewed this almost every year. Does that make sense? Do we need more examples, or are you pretty much good with that? Give me a 1 to 5. Okay, you good? 4 means you got it. You're ready for the test.
Yeah, no, 3.
You ready to practice on your own?
Yeah.
Okay. All right, then. We're moving on to number 2. I kind of was expecting greatest common factor to be kind of one that needs to be just looked at, but I think you pretty much have that. Although I will say, it is the one most missed. So whenever you see a problem, the first thing you do is factor out the growth in common. Now the second one, number 2, we have what's called special cases. And you can always tell these because they have 2 terms. Or if you prefer, these are binomials. Okay? So that's the clue, that's what you're looking for. You're looking for a problem that says the factor, but you realize it's a binomial. Okay, it's probably going to be a special case. Okay? So, what do you do first with the special case? Once you identified it, what do you do first?
Circle it.
No.
Do you figure out the biggest exponent?
No.
GCF.
You always do GCF first. First thing you do is take out what's in common. Okay, if there's something in common between both of them, you take that out first. Always, always, always. If there isn't any, then we're going to identify what type it is. 2 basic types. We'll cover both today. The first one is the difference of 2 squares. So it says difference, which means we have to have what type of operation?
Division.
Not division.
Subtraction.
Subtraction. Difference is subtraction. What's the difference between 5 and 10? Well, it's 10 minus 5 is 5. Okay? So the difference. And then we have to have 2 perfect squares. Now, for those of you who haven't for Algebra 2, we have on the board over here a white piece of paper that had all the perfect
Yeah,
squares.
we should put that back.
Yeah, we should. So 1 squared is 1, 2 squared is 4. What are the perfect squares? Keep going. Shout them out. What's the next one? What'd you say? 3 squared is 9. 16. 25.
6 squared, 36.
Keep going.
7 squared, 49.
There you go. Keep going.
8 squared, 64.
Perfect. Keep it up.
9 squared, 81.
Yep.
10 squared, 100.
Yep. Keep going.
11 squared, 100. No.
121.
Okay, I got it mixed up.
Keep going. 12 squared.
140.
Yep.
Keep going. 13 squared. What'd you say?
Yeah, we'll get it back that far.
169.
Yeah.
14 squared. 196. 15 squared. 225. Okay, so when we look at the difference of 2 squares, what you're doing is you're identifying. You have to know those numbers. Because as you look at it, you're identifying, hey, there's a perfect square in this problem. We see what's in common, pull out the greatest common factor. One of these squares should be left. So for instance, we have something like x squared minus 9. The 9 is a perfect square. We have in front of the x and understood 1, that's a perfect square. Now, when it comes to variables, how do I know this x squared is a perfect square? What would the exponent always be? Not just 2. What type of number will that exponent be? Starts with an E. Not odd, but even. That exponent will be even. Anytime you have an even exponent, you're going to have a perfect square. So if I have x squared minus 9, once again, there's nothing in common. We don't factor on the greatest common factor. We realize there's a difference of 2 perfect squares. Once you memorize it, then it's just a matter of, okay, what's the square root of x squared? X and x. What's the square root of 9? 3, so 3 and 3. 1's plus, 1's minus, and you're done. Now, let's do one. What if that x squared is actually x to the 4th minus 9? Okay? The difference minus 2 perfect squares. What's the square root of x to the 4th?
2.
It's just, well,
Wait.
it's, what's 2?
A number?
The exponent is 2. So
Okay.
x squared and x squared. I knew you were thinking that. I just want to make sure I heard the exponent. So x squared, and then 3 and 3. 1's plus and 1's minus. Now, I have the difference. X squared is a perfect square. Is 3 a perfect square? It's not. There's my answer. There's my prime numbers. I factored it down into its primes. The difference of 2 perfect squares. All right. You try this one. How about x squared minus 81? Then I have a tricky one for you.
Wow, you're so quick. You should put your answer on the board and I'm okay.
You want to do it?
Yeah.
You got to go on camera. Are you okay going on camera?
No, I'm not.
Okay.
I'll do it. Yes.
You want to do it on camera?
Hold on, guys. I couldn't breathe.
I didn't.
Oopsie. Wait, it's this way.
Beautiful. Exactly right. Square root of x squared is x. Square root of 81 is 9. X minus 9 is plus 9. Okay. You ready for a tricky one? Let's do that same example. And let's do x to the 4th minus 81. Back to that. You thought it was tricky?
You said it was tricky.
It is tricky.
So,
You don't think so?
if I get this wrong, it's not my fault. I don't think it's tricky.
See, I don't know if I like that. If you get it wrong, it's not my fault. But if I'm telling you it's tricky, you should be looking out for something that's tricky.
I'm looking.
Quinn, you got this answer?
Yeah.
Okay, what'd you get?
I got x squared plus 9 times x squared minus 9.
Final answer?
No.
No, actually,
Why not?
because 9 is a perfect square, isn't it? So you have to make it even smaller, right?
Yes, you do.
Wow. Quinn.
Wow.
Look at this
Cannot
smarty
believe
pants.
it.
Look at this smarty pants.
So x squared minus 9 is a little tricky because you now have to x to the 4th, so now you have to break it down again. And what do you get?
X plus 3 equals minus 3.
There you go.
Wow.
So just because we factored it once doesn't mean we're completely done. You got to check out what's left.
Yeah.
That's why I said it was a little tricky.
Well, I was looking for it and then found it.
You found it when you said it out loud?
Yeah.
All right, one more because you're going to see some of these on homework. One more example where rather than just an x in the front, we have a number there as well. So like 25 x squared minus 144. So nothing in common between 25 and 144. So go from there.
But they are perfect squares.
They are. They're on our list. answer?
Yes.
Omar, what'd you get?
5x plus 12 and 5x. Oh wait, sorry. Plus 14. No, 12. Sorry. Plus 12 and then 5x minus 14.
Very good. 5x plus and 5x minus 12. Okay, we're good with this?
Yes.
All right. Now, part A was difference of two squares. Remember, we have a binomial, we have two terms. First thing I look for is
GCF.
greatest common factor. Then if I don't have a greatest common factor, we see if they're perfect squares. If they're not, sometimes, capital V, they're the sum and difference of perfect cubes. Okay, perfect cubes. So let's start that list. 1 cubed is going to be 1 times 1 times 1, 1. Okay, 2 cubed is going to be 8. 2 times 2 times 2. What's 3 cubed?
Isn't it?
27.
27.
It's 27.
Yeah. You just did it for me.
What's 4 cubed?
Yeah, I'm not going that far. Wait,
64.
64. 64 is an interesting number because it's a perfect cube as well as a perfect square. So you see
So
it.
what do you do?
I'm sorry?
So,
It depends on what the other number is.
oh,
If the other
okay.
number's a square, you take 8. If the number's a cube, you take it. Okay, so 5 cubed.
Isn't it? Wait, I don't know. Isn't it? It wouldn't be
125.
125.
How about 6 cubed? $216. How about 7 cubed? 343. How about 8 cubed? 512. How about 9 cubed? 729. And you all can do 10 cubed. What's 10 cubed? So they go up very quickly, but these are the perfect cubes. These are the numbers we're looking for. Okay? Now, I have a formula for this one. I'm going to give you the formula, and we're going to look at it on Thursday after the quiz. Don't forget the quiz is on Thursday. So we'll continue up with perfect cubes on Thursday, but at least I'll give you the formula today. Okay? So write this down in your notes. Formula, if it's little number 1, whatever, we're going to have a cubed plus b cubed. Okay, just like we had a squared minus b squared or whatever, now we have a cubed plus b cubed. Here's your formula. Some of you I hope remember from last year, or in Quinn's case 2 years ago. A plus b times a squared minus ab plus b squared.
Yeah, I don't remember that.
There's your formula. Honestly, not too many people do. I really wouldn't
Sure,
expect you
we
to.
did this. When did we learn this?
Last year,
Like, when?
Now with that, remember I said the sum and difference, right? So there's a difference one as well. So we're going to have a cubed minus b cubed. It's going to be equal to a minus b, a squared plus ab plus b squared. What's the difference between the two formulas as you write them down? What's the difference between the two?
For the sum, the a plus b, it's a plus, and then a minus b.
So if you look at them, this sign here is the same as this one, just like negative and negative, right? What do you notice about the second sign?
This one's opposite.
This one's positive, this one's negative. This is negative, this is positive, right? So it's the opposite. What do you notice about the last one?
They're the same.
And they are
Squared.
always positive. So if I've taught this to you before, the word soap, same, opposite, always positive.
Ah.
Now come back on Thursday, take the quiz, and then we'll show you how to actually use this formula. It's a plug and chug situation. That's the way it be. So
So wait,